In this video, we are going to show the process of building a powerful and simple single-stage coil gun that can be made quite compact due to the usage of a custom PCB. This PCB houses the whole charging and discharging circuit of the coil gun and is powered via a single 9-volt battery, so that the place for external components can be kept pretty low. With this PCB, we built a coil gun that is capable of firing an 8mm iron projectile at around 20 meters per second. It uses the energy of a 300-volt 1000 microfarads capacitor, which gets rapidly discharged into a coil that has around 250 windings of 0.6 millimeters of copper wire. But before we show further details on the build process, it's important to be aware of the dangers of the high voltage involved in this project. The energy of the used capacitor is enough to kill you, so if you don't know how to properly deal with high voltages, this project is not for you. That being said, let's go on with the basic working principles of the circuit. The circuit uses a boost converter in order to boost the 9-volt input voltage to the desired output voltage with a maximum of around 500 volts. The voltage to which the capacitor needs to get charged, in our case 300 volts, can be individually set via a potentiometer. When the so-called cutoff voltage is reached, the oscillator in the boost converter stops oscillating and the gun is ready to fire. As soon as the trigger button gets now pressed, the capacitor discharges into the coil through an SCR. The SCR fully drains the capacitor till it has no voltage anymore, since the SCR can't be turned off as long as there is still a current flowing, unlike a MOSFET or IGBT. However, this is not a big problem, because with a single-state coil gun like this, you do not necessarily need a coil that gets turned off manually on a specific time. With the coil staying on till the capacitor is fully drained, the on time of the coil is calculated by the charge of the capacitor and resistance of the coil. The bigger the charge and the resistance, the higher the resulting on time. With that in mind, you sometimes need to adjust the values of the capacitor according to the value of the coil, so that the on time is not too short or too long. For example, a capacitor of 1000 microfarads with a voltage higher than 300 volts will lead to a smaller velocity in our coil gun, since the on time of the coil is going to be too long, which results in a suckback of the projectile and in a resulting decreasing velocity. When the built-up magnetic field of the coil suddenly breaks down as soon as the capacitor gets fully discharged, a reverse current is built up in the coil that can destroy a SCR, capacitor or boost converter. To solve this problem, we need to give the current another way to flow besides through our components, which is why we use a diode in parallel to the coil. However, because the reverse current gets now drained through the coil, this also increases its on time. To prevent this from happening, you need to choose a high voltage diode with a high forward surge current rating, ideally over 500 amps. There are also other more advanced ways to deal with the reverse current, as well as other factors than the on time that are important for a powerful coil, but these would go beyond the scope of this video. Now coming back to the boost converter topic, the boost converter has a pretty large inductor in order to overcome the big difference between the input and needed output voltage. It is also designed to work on low input currents, specifically below 200 milliamps, so it doesn't overdrain the 9-volt battery or similar small batteries. For the actual building part, we just used the case of an old toy gun, where we glued a coil, capacitor, buttons and the PCB with the charge and discharge circuit on. All in all, this coil gun reaches an efficiency of 4%, with the input energy of the capacitor being 45 joules and the energy of the projectile being 1.8 joules. This is a pretty decent efficiency for a single-stage SCR-driven coil gun. So if you want to remake the project, you can buy the PCB files over the link in the video description, or you can of course build your own circuit. However, keep the on time of the coil in mind if you want to use different capacitor and coil values than the one we used. Also don't forget that this is not a toy gun and it can possibly hurt you or others.